Hello to everyone. In this video, let us discuss 7th A group elements halogens. So, what are the general properties of halogens? So, let us see here. First, what are 7th A group elements? Fluorine, chlorine, bromine, iodine, astatine. These are 7th A group elements of P block in periodic table. And what are the atomic numbers? Fluorine atomic number 9, chlorine 17, bromine 35, iodine, just reverse it, 53, and astatine 85. These are the atomic numbers of 7th A group elements. And general electronic configuration is NS2NP5. And all these are known as which one here? Halogens. 7th A group elements are called halogens. Why? Because they are sea salt producers. That means they produces which one? Sea salts. That means here that more available, they are more available in which one? Means sea water. For example, if you consider NaCl, seawater contains 25% by mass of NaCl, and seaweeds contain 0.5% of iodine. So seawater contains sodium chloride, sodium bromide, magnesium chloride, magnesium bromide, etc. And chili saltpeter means NaNO3 also contains sodium iodate, NaIO3. So like that, as these are that present in seawater, as they are producing sea salts, they are known as which one? Halogens. And here let us see the abundance of these elements. So now here which one here? Fluorine. The important mineral of fluorine, which one here? Means fluorospar. Fluorospar is the important mineral. What is the formula of fluorospar? Means CaF2. Okay, then another important mineral, cryolite. What is the formula of cryolite? Na3Alf6. And another important mineral is which one? Fluorapatite. Fluorapatite formula Ca3PO4 taken twice dot CaF2. So that is the formula of which one? Fluorapatite. So these are the important minerals of which one here? Fluorine. Okay, then now let us see the speciality of halogens. Each and every halogen has its own speciality. What are the specialities? Fluorine is known as a super halogen. Because of its high reactivity, it is known as a super halogen. And chlorine speciality, high electron gain enthalpy possessed by which one? Chlorine in entire periodic table. That is the speciality of chlorine. And bromine speciality, generally all non-metals present in gaseous state, but bromine present in liquid state. So the liquid non-metal, only one, that is bromine. And what is the speciality of iodine? Generally all halogens, due to the NS2NP5 general configuration, they always gain one electron and exhibit -1 oxidation state. But iodine exists as I plus 1 by losing one electron. And by losing one electron, it acts as a reducing halogen. So that is the speciality of iodine. So which is reducing halogen? Means iodine. And what is the speciality of astatine? Means it is a synthetic halogen having short half-life period. So it is radioactive halogen. So these are the specialities of which one? Halogens. Okay, then After that, let us go for which one here? Those general properties. So first let us see here atomic size. So what happens? Atomic size means from fluorine to iodine. So no need to consider astatine as it is radioactive element. From fluorine to iodine, what happens? Atomic size increases. And then come to ionization potential. Ionization potential decreases from fluorine to iodine. And then electron affinity or electron gain enthalpy. Generally electron gain enthalpy decreases from top to bottom, but in each and every group second element electron gain enthalpy greater than that of first element. So now here chlorine greater than fluorine greater than bromine greater than iodine. So due to smaller atomic size, fluorine means F, has high interelectronic repulsion. So that's why only its electron gain enthalpy less than that of which one? Chlorine. Okay, then after electron gain enthalpy, next one is here which one means color properties. So now all halogens absorb the radiation from visible region, that means from VIBs, and they exhibit which one? Different colors. Okay, now first let us go for fluorine. Due to smaller atomic size, it absorb high energetic violet color and emit its complementary yellow color. So that means fluorine appears in which color? Means yellow color. But the question sometimes you may get like this here. F, that means fluorine absorbs dash color and emit dash color. So fluorine absorbs high energetic violet color and liberates less energetic yellow color. So it appears in which color? Means yellow color. And chlorine is having greenish yellow color. And next bromine is having reddish brown color, or you can take it as red color. And iodine absorbs least energetic yellow color, but that appears in which one? Violet color. So due to larger atomic size, iodine absorbs less energetic yellow color, and that appears in which one? Violet color. So these are the colors of which one? That halogens. Okay, then thereafter let us see which one here? Bond dissociation enthalpy. Bond dissociation enthalpy order, or we can call that as bond energy order. So generally what is expected bond energy order here? As atomic size increases, bond length also increases. As bond length increases, bond energy decreases. So expected order is which one? Fluorine greater than chlorine greater than bromine greater than iodine. So this is the expected bond energy order. But what is experimental? What is experimental bond energy order? See here, what is that order? Cl2 greater than Br2 greater than F2 greater than I2. That means here experimental values indicate that fluorine has F2. F2 has least bond dissociation enthalpy than which one? Cl2 and Br2. So for that, two explanations are given. Why F2 is having less bond enthalpy comparatively with Cl2 and Br2. So in that, first explanation given by which one? Mullikan. What is that Mullikan explanation? According to Mullikan explanation, due to the absence of vacant d orbitals. If you consider ns2np5 configuration, only one unpaired electron is present. Only one unpaired electron present in case of which one? Fluorine. Because fluorine is not having vacant d orbitals. So one fluorine can form a single bond with another fluorine only. That means in between two fluorine atoms, only single bond is possible. But in case of chlorine and bromine, in remaining halogens, due to the availability of vacant d orbitals, excitation of electrons may take place. So that's why in between two chlorine or two bromine, any other halogen atoms, multiple bonds are formed. So now it is difficult to break multiple bonds comparatively with a single bond. So according to Mullikan, what is the reason for less bond dissociation energy of fluorine? F2 means fluorine has only single bond, but remaining halogens having multiple bonds. So due to that, F2 is having less bond energy. But actually, this explanation was not true, because in between any two halogens, always only a single bond is possible. So this is not the correct explanation. And then another explanation was given by Coulson. So what is that explanation? See here. According to Coulson explanation, see here, each and every halogens having three lone pair of electrons. So if you consider two fluorine atoms, here three lone pair of electrons and three lone pair of electrons are present. But in case of chlorine also, three lone pair of electrons. But in case of chlorine, the lone pair of electrons are somewhat having some distance among them, somewhat distance to one another. But in case of F2, the lone pair of electrons are very close to one another. And we know that lone pair having repulsion. So now here, due to the very close approach of this lone pair of electrons, that repulsion is to a greater extent. For that reason, this bond will be broken easily. But in case of other halogens, that lone pair of electrons are at somewhat distance. That means the repulsion among them is somewhat less than which one? F2. So for this reason only, due to the lone pair of electrons, that due to that greater lone pair of repulsion, F2 is having less bond dissociation energy than Cl2 and Br2. So this is the Coulson explanation. So this is the more accepted explanation for the less bond enthalpy of fluorine. So we have to remember this thing. Fluorine has less bond dissociation enthalpy. Okay, then after that, what are the remaining properties are here means oxidizing power. So what is oxidizing power? How you can say as oxidizing agent these are acting means, see here, if you consider any halogen, due to ns2np5 configuration, halogen atom or halogen molecule gain electrons and they try to convert into which one? X minus. So by gaining one electron, they get into inert gas configuration. So that's why all these halogens try to gain electrons and themselves they undergo reduction. They are undergoing reduction means they act as oxidizing agent. But here, which is a strong oxidizing agent among all the halogens? How to determine that fact means this total phenomena takes place in multiple steps. See what are the steps here. If any halogen present in solid state, that should be converted first into liquid state, then that should be again converted into gaseous state, then that should be dissociated into atoms, and therefore by adding electron that can be converted to X minus, and by dissolving in water that converts into X minus aqueous. So if any halogen try to gain one electron means this total process should has to takes place. It has to takes place. Now in this total process, which halogen is having more negative enthalpy, that means in which case more energy is liberated, that halogen only said to be which one strong oxidizing halogen. So now first let us see in which, in among all these steps, in which we are losing energy, in which step we are gaining energy. So in this step we are losing energy because conversion of solid to liquid means we need to provide some heat energy, and here also we are losing energy. This is also loss for us. And X2 to X means bond dissociation enthalpy among chlorine, bromine and fluorine. In case of fluorine, we need less expenditure for the conversion of molecule into atoms. So that point we have to remember. And then final step here, X minus when dissolved in water, the heat energy liberated is called heat of hydration or hydration energy. Hydration energy is more for smaller species. That means among all these three, F minus is having smaller atomic size. So for fluoride ion, more heat energy is liberated. So now let us see here. First, as bromine present in liquid state, we have to expend somewhat more for that process. And iodine present in solid state, some extra amount of heat energy we have to provide. So for bromine and iodine, there is no chance to get high heat energy in this process. So those two are already removed from the competition. Now come to chlorine, bromine and fluorine. Among these three, of course, bromine also present in which state? Liquid state. So for this also we have to give somewhat extra amount of heat energy. Okay, that is also removed from the competition. And in this competition, chlorine and fluorine only present up to here. But see here, conversion of X2 into X, bond dissociation enthalpy. In between Cl2 and F2, F2 has less bond dissociation enthalpy. That means we have to invest less amount of energy in case of F2 comparatively with Cl2. So now there are some chances for F2 to win this competition. Now again come to the last step. Now heat of hydration. Heat of hydration is more for small species. So F minus is smaller than Cl minus. So in this case, we get more heat energy in case of which one? F minus. So finally, in entire halogen family, F2 won the race. So that's why, due to what are the reasons to win this competition means, due to low bond dissociation enthalpy and high heat of hydration among halogens, fluorine has the high, which one? High oxidizing power. So that's why only fluorine can displace all its below halogens from their which one? Halides. So for example, if you consider fluorine, chlorine, bromine, iodine, fluorine present at the top. For example, in a cinema theater, these are present like this. So fluorine present at the top, iodine present at the bottom in a theater. Now, who can kick all the members means of fluorine. So that's why fluorine can displace all other halogens from their halides. Okay, then chlorine displaces bromine and iodine from their halides but can't displace which one? Fluorine, because fluorine is present in above row in the theater, like that you have to think. And bromine displaces iodine from its halide but can't displace which one here? Chlorine and fluorine. And iodine can't displace any other halogen from their halides. It can be displaced by all the halogens. So which halogen can displace or which halogen can oxidize all other halides, all other halogens means fluorine, and which halogen can be displaced by all other halogens means iodine. Or in a simple language, the halogen which kick all other halogens means fluorine, the halogen which can be kicked by all other halogens means iodine. So the questions we can get like this here. Fluorine plus 2KCl gives 2KF plus Cl2. Is this reaction possible or not? Yes, it is possible, because as per this equation, fluorine displaced chlorine, or fluorine oxidized chlorine, or fluorine kicked the chlorine. So we know that that is possible. And now another reaction I give here, Br2 plus 2KCl gives 2KBr plus Cl2. Is this reaction possible? Means no, this reaction is not possible, because bromine present at the bottom, chlorine present at the top. So this reaction is not possible. So like this they give the questions regarding oxidizing power. Okay, then let us see oxidation states. So common oxidation state of halogens is which one? -1. And fluorine always exhibits which one? -1 oxidation state in its compounds. And in ground state, other halogens can exhibit along with -1 +1 also. In first excited state, halogens exhibit +3 oxidation state, and in second excited state, these can exhibit +5. In third excited state, these halogens can exhibit +7. So these are the different oxidation states of which one? Halogens. Fluorine exhibits always -1 oxidation state. Of course, in elemental state, they exhibit 0 oxidation number also. So these are the general properties of which one? Halogens. Okay. In our next video, let us see the chemical properties of halogens. Okay, bye.